Hey there, my name's Gary Sims and this is Gary Explains. Now, I recently did a video on finite state machines and I showed how to implement them using Python. Some people have asked for a C version. This is a really quick video in which I just show you very quickly how I've implemented it in C, and then of course the code will be available on my GitHub repository. So, finite state machine in C. Are you ready? Let's go. Okay, so we start off with a couple of type defs. The first one is the list of the different states that our state machine can go through. Now, if you haven't seen the previous video on finite state machines and how we do the verification of floating point numbers in Python, some of this is not going to make any sense. You really should watch that video. If you have, so you're following along, good. You will have noticed there are two things that are different here. First of all, we've got this valid end states state that I've put in there, and I've put it with a underbar at the beginning to show that it's an internal state, not one of the states of the machine that we're actually using. What it basically means, if anything after here, which is second digit onwards and mantissa, is a valid end state, and that's a good way for us to detect whether more input was needed or whether we're now in a valid end state. And of course this is C, so we're dealing with pointers and so on, so we need a marker like the zero, the zero at the end of a string to know this is the end of our list, okay? And we use that later on. So those two are internal states, and the rest of the states here are exactly as we find them in the Python code in the other video. And then we also have here a structure that we turn into a type def that basically lists the different states and the tokens. So you've got the state you're currently in, so that's what we define, the list of the tokens that you can use to go on to the next state, and the next state that you then move into, exactly as we did in the Python code, but we're using it now in C. Now, the run function is fairly simple, but it's good to just see what you need to do here. So in the run function, when you run the finite state machine, you tell it what state you start in, of course. We need a pointer to the finite state machine, which is all the different states with the tokens and so on that we're just creating. And then you need the cargo, that's the data, in this case, the floating point number that you want to check against. And we just define some variables here that we're going to use in a moment. P is kind of our current pointer into the state machine. Current state, well, that's obvious, it's the current state, and you set it to initially to be the starting state. Found is going to be a pointer to somewhere in the state machine to say we found a token, which means we can move on to the next state. And we're going to use a pointer called C, which allows us to move our way through the cargo and checking the numbers as we go along. So here's the main while loop that you find inside the run function. What does it do? It basically does a while all this stuff while basically you haven't got to the end of your cargo. So you're doing it one letter at a time, and you'll notice down here we've got C++, haha, no pun intended, C++, which basically moves its way through the different digits and symbols in this floating point number. And when that gets to the end, then there's no more input, so you've got to make a decision, was this a good number or a bad one? And what you basically do is you say, well, are we at the end of our list of states? Because we're going to go through them one at a time, and so that's our marker to make sure that we're at the end. And you basically go through them, you say, is this state related to the current state? Is this an entry for the current state? And if it isn't, you just do a P++, and of course the great thing about C is because it knows that P is a pointer to that structure that we created, then it moves on the right number of bytes. It's not a 1 byte or a 4 byte increment, 64 bits, it goes over the whole structure. Great thing about C. So we go through all of them, and if we find that this is a state relating to the state that we're currently in, we basically check to see whether the letter, the digit that we're looking at, or the symbol we're looking at is in the list of tokens. If it is, then we know it's a valid token and we can move on to the next state. Now this goes through this in a iterative manner, starts at the beginning, goes through all the states. There are more efficient ways to do this. I will say there are more efficient ways because we're not using even a lookup inside an array, indexing an array directly. We're actually going from the beginning to the end saying, is this the right state? Is this the right state? Is this right? It's just easy. Okay, there would be more efficient ways, but to explain it, this is just the easiest way to do it. Now, once you've found a state, you basically say, well, in that case, then let's change the current state to whatever matched to the next state, and then chop a character off our string. So that's what happens if you can't find anything after you've been through all the states in the state table that match the current state. and you can't find a matching string in the tokens, that means you failed. So at this point we just fail. We failed and we return -1 from the run function to show that we failed. And after that while loop, which means we've now got to the end of our string, we need to know whether we finish in a good state or not. So if the current state is greater than, and here's our internal thing, valid end states, then we know that we've got to a good place. So it meant it finished in Mantissa, for example. So we know that's okay. If it isn't, then we know that it's a bad state. We've ended up in a bad place, and so more input would be needed. And finally, here's the main function. So here is how we define our state machine. Start. Well, we want 1 through to 9. You move on to the second digit onward state. Second digit onward state here says you can have 1 through to 9, which takes you back to the second onward digit state. Or, of course, you can have a dot. If we look at the other start state here, if you have a minus, you go to, and exactly the same as we had in that Python code. Again, you've got to have watched that video to understand all these transitions here. And this last one here, last state just gives us the end of this list, so we know that we don't run over the end of it. So you can define whatever it is you're looking for just by creating this array here of all the different states and the tokens that you want to go into them. And then here I've got the test where I've run through all of those different things, and the results are exactly the same as in our Python code, good and bad as you would expect. Okay, that's it. As I said, very quick video. I hope you enjoyed it. If you did, please do get a thumbs up. Don't rely on the YouTube recommendation algorithm. Better to subscribe and hit that bell notification icon. Okay, that's it. I'll see you in the next one.